As welcome to my YouTube channel, and please don't forget to subscribe for more videos. So today we are going to see, or we are going to talk about the interpretation of structural drawings, or the interpretation of structural members in a drawing. So when we talk of the structural members, we have a beam, we have a slab, we have a column, we have a staircase, we have foundations. These are structural members. So we are going to see a sample of a drawing from our computer so that we can see how we interpret these drawings, so that it can be useful to a site person or a site supervisor or anybody who is on the site doing quality control and supervising the constructions on site. So as we switch on to our computer, we are going to start with the beams. So in our drawings, in our interpretation, we have two types of beams here. We have an L-beam. You see this type of a beam, its detail is in L-shaped. So that's why we call it an L-beam. And then we also have a T-beam. You can see this detail here. It's like a T. It forms a T. Its detail forms a T. So that's why it's called a T-beam. And mostly T-beams are found at the centers of the slab, while L-beams are mostly found at the edges of the slab. So we have beams here. So we are going to interpret this beam. So as you can see, this is a longitudinal section of a beam. And this beam, it has been indicated that it is L-beam A and F. L-beam A and F. So as we go back to our, if we can go back to our slab detail, our L-beam A and F, this is now according to the grid. Now if you look at our grid on the slab, we have these grids. We have got grid A up to grid F. So grid F and grid A, these are L-beams. These are beams that are found at the edges of the slab. And that's why this beam, it has been denoted as beam detail A and F, and hence it's an L-beam. So the detailing of this L-beam, according to its reinforcement, is that this beam, it has been designed as a doubly reinforced beam. A doubly reinforced beam, it means that it has got bars that undergoes tension, and it has got also bars that are undergoing compression forces. So here, the bars on this L-beam, the bars that are under tension, they are these bottom bars. And the bars that are under compression, they are these top bars. So the tensile bars, we have been given that we have got three. As you can see, we have got three Y20 bars. So as you look on this detailing, we have got 1, 2, 3. So these are three Y20 bars. And then still on the tensile reinforcement, there is an additional of 2. I've got 2 Y16 bars. So these are the 1, 2 and 2 Y16 bars. So in total, the reinforcement bars under tension force, there are 5. So we have 1, 2, 3, 4, and 5. These are reinforcement under tension on that beam. And then the reinforcement under compression on this beam, and this is the reason that this beam has been designed as a doubly reinforced beam. We have got these two beams here, 1, 2. So these two beams, we have got 2 Y20 beams. So these are 2 Y20 reinforcement bars. and these are the bars that are undergoing compression forces on this beam. Hence the beam to be called a doubly reinforced beam. And then on this beam also we have got stirrups. There is something we call stirrups, or we can also call them rings. This is the reinforcement that binds the main reinforcement bars. So these stirrups, according to our beam, the stirrups, you can see this detail is that these stirrups, it has been denoted R6. So it is a bar diameter R6. It is a bar diameter R6. And it has been put at a spacing of 100 millimeters center to center. So the spacing of the stirrups on this beam is 100 millimeter center to center. So, and you can see also on this beam, we have been given the slab thickness. The slab thickness is 150. And then the overall beam depth. The overall beam depth on this detail we have been given to be 450. And then the breadth of the beam, that's the width of the beam, it has been denoted here as 200 millimeters. So this is the interpretation of that L-beam. So when we come to the T-beam, this T-beam, this is the cross-section of the T-beam, longitudinal cross-section of the T-beam. And this T-beam, you can see it has been denoted T-beam B, C, D, and E. So when we go back to our plan, our detail for the slab, so that we can see those grids, we have got B, C, D, and E. B, C, D, and E. So these are the T-beams. So according to our slab structural detail here, you can see these are the beams that are in the middle of the slab. So you can see this one is our grid B. So you see we have our grid A here. We have our grid A. From grid A, we go to grid B. So you see grid B, it comes at the center of the slab. So that's why it's called a T-beam. So we have grid B, we have grid C. As we go on, E, F. So grid F, we have already said that is an L-beam because it's at the edge of the slab. Grid E, that is a T-beam. Grid D, that's a T-beam. Grid C, that's a T-beam. Grid B, that's a T-beam. So that's why this beam, it has been denoted as T-beam B, C, D, and E, because these are beams that occur at the center of the slab. So the detail also for this T-beam is according to the structural analysis that was done, it's like the detail is almost similar with that of the L-beam. So we have got 3 Y20. These are tensional bars. In addition, we have got also 2 Y16. So in total, we shall have 5 bars under tension. And then we also have got 2 Y20 bars at the top. These are reinforcement under compression. As well as we will have the stirrups, which are the rings, which is still R6 at the centers of 100 millimeter. That is from each other, center to center. Again, as you can see, the slab thickness is 150, and then the overall depth of the beam, as you can see, is 450, and the breadth of the beam is 200. So that is the detail of that structure. And then there is something that we should be careful about when we are interpreting these details. We have got something we call covers to reinforcement. And covers to reinforcement, as we know, is that minimum covers to reinforcement. Minimum covers to reinforcement. That is the cover, that is the thickness of concrete that covers the reinforcement from not being seen, so that it cannot be seen. So, because the reinforcement is not supposed to be seen when the concrete has been casted. So, like for example here, the minimum covers to beam is 20 millimeters. The minimum cover to the slab is 15 millimeter, as well as the minimum cover to the columns is 40 millimeter. The minimum cover to the staircase shall be the same as the minimum cover to the slab, which is also 15 millimeter. The minimum cover to foundation shall be 50 millimeter. So if we go back to our detailing, you can see we have a space between the stirrups, because the stirrup will be the reinforcement on the outer surface. So the space between the stirrup and the concrete, so you can see this is the line of the concrete. So this space here, that's what we call the cover. That's what we call the cover to reinforcement. So this is concrete. And we have been told that the minimum cover to reinforcement in a beam detail is 20 millimeter. So this distance, that is what we call the cover. And since we are talking about the beam, then this is 20 millimeter cover. Thank you for watching my video. Next time we shall be talking about the slab, the column, the staircase, and the foundations. Thank you very much. Don't forget to subscribe.